All right, everybody, welcome to the video here for lesson number 1 in Unit 1 for Algebra 2 Accelerated. So one of the things that we learned in class today was multiplying polynomials, and I don't even want to say learned, I would more say review from some of the things that you did way back in Algebra 1. So first question, this should be very straightforward, super easy question. If you're going through and doing this problem, you're either going to use the tabular method, making your boxes, or distributing. This one's pretty easy, so I'm just going to do the distributing method. So it's going to give me x squared. That's going to give me 5x minus 4x and minus 20. Just watch your signs. Then we have some combining of like terms here in the middle. So we wind up ending here with x squared plus x minus 20. This is an example of a quadratic trinomial. For number 2, this one I am going to use the tabular method for. So we have a 2-term polynomial, a binomial, multiplied by a 3-term. So that's how I know to make 6 boxes. 2 times 3 is 6. So if I have x times x squared, that gives me x cubed. X times negative 4x is negative 4x squared. X times 4 is just 4x. 3 times x squared is just 3x squared. 3 and negative 4 give us negative 12x. And lastly, we just get 12. We have some like terms here. So I'll draw my arrows, negative x squared. I'll draw my arrows. That gives me negative 8x. So my final answer here is x cubed minus x squared. Notice I'm going in order. Minus 8x plus 4. This is an example of a cubic polynomial. All right, next problem. So this is a 3 by 3, right? So we could do the box method here or the distributing method. Really doesn't matter. I'll do the box method here again. So 3 by 3 is going to tell me to make 9 boxes. So I have x squared, negative 3x and 9, x squared, positive 3x and 9. So I have x to the 4th, 3x cubed, 9x squared, negative 3x cubed, these cancel, negative 9x squared, these cancel. Look at that. Now we have negative 27x. 9x squared. That has nothing to cancel with. 27x. Got another cancel. And 81. So our final answer here is going to become x to the 4th plus 9x squared plus 81. This would be an example of a quartic, Q-U-A-R-T-I-C, trinomial. For number 4, I'm going to use the distributing property. So if I distribute here, 2r times 2r squared is 4r cubed. 2r times 1 is just 2r. 1 times 2r squared is just 2r squared. And 1 times 1 is 1. No like terms, but this is not written in the right order. So I want to rewrite this as 4r cubed, making it cubic, plus 2r squared plus 2r plus 1. Number 5 is no different than anything else. Just have 4 terms by 3 terms. So that means I need a whole bunch more boxes than I had in the last few problems. So this one for sure I'll use boxes for. So if I have 3 terms by 4 terms, I need 12 boxes. So I'll put the 3 terms on top, m squared minus 5m and minus 6, and the 4 terms on the side. So when I do some multiplication here, I wind up getting 3m to the fifth. Remember, when you multiply variables, you add their exponents. 2m to the fourth, negative 2m to the third, and negative 5m squared. With the middle column, I'm going to get negative 15m to the fourth. These are like terms, so that's good. That gives us negative 13m to the fourth. Negative 10m cubed. 10m squared. And 25m. Another nice thing about the tabular method, there's a quick check. Every column, the exponent should each time go down by 1. Last column, I have 18m cubed. I have negative 12m squared, positive 12m, and positive 30. So again, let's look for those like terms. So I have negative 30m cubes. I have negative 7m squareds. And I have 37m. So our final answer here, if we put it all in order, is 3m to the fifth power minus 13m to the fourth power minus 30m to the third power minus 7m to the second power plus 37m plus 30. This is just an example of what we would call a fifth degree polynomial. There is a special name for m to the fifth power. I believe it's called quintic, but you don't need to know that. All right, let's look at number 6. Number 6 has 3 separate parentheses, so we need to take 2 at a time. So this first one, t minus 1 times t plus 1, if you do some quick distributing there, or if you remember the rule from class, anytime you have a t or an x minus 1, the minus 1 is going to create some cancellations. The other thing that you might remember from way back in Algebra 1 is that factors from the expression t squared minus 1. All right, remember difference of 2 squares? So that kind of helps you. So essentially factoring might actually help you do multiplying quicker because you're just doing the opposite thing. Now, if you really have to, you can go through and do your boxes or your distributing. You're going to get t squared minus t plus t minus 1. The t's cancel. That's where the t squared minus 1 comes from. Well, again, if you know that same rule again from class, or if you remember the factoring method here, you kind of don't need to do so much work for the second part of number 6. I know I'm going to get t to the fourth. I'm going to get a t squared and a negative t squared. Well, they're going to cancel. So I'm going to be left with minus 1. That would be considered a quartic binomial. All right, let's go on to the review questions. Now, I always add a couple of review questions in the accelerated class towards the beginning of the year just to kind of see what you all remember from Algebra 1, because if there are things that we can go through quicker that are old stuff, that might help us out here. So let's look at number 7. Number 7 asks us to factor each of the polynomials completely. The first one is difference of 2 squares. So we make 2 parentheses. I know t multiplies to t to make t squared. Since there is no middle term, I know my signs are going to be opposite. So I have a plus and a minus. And then I just have to ask myself, well, what multiplies to itself to make 25? 5 times 5. The second one here has a common term of 2. So a GCF of 2 divides out, leaving us y squared plus 3y plus 4. And then we have to use another factoring method to factor that middle part there. Y times itself is y. What multiplies to make 4, but adds to make 3? Well, anything, right? So 4 has 4 and 1 that adds to make 5. 4 has 2 and 2 that adds to make 4. So there is no more factoring there, and we're done. For the last one, there is no GCF, so we have to do our factoring method here. So depending on who you had for Algebra 1, they might have showed you how to do this a little bit different. I'm going to do it how the middle school teaches it right now, and in class I'll show you how the high school teaches it, which is slightly different. So in the middle school they teach this as guess and check. So we put 2n in the first spot and n in the second spot. Why? Those two terms multiplied together to make 2n squared. Then if I put a 3 in the first spot and a 1 in the second spot, both are pluses, I now guessed that that's the right factors. Unfortunately for me, when I check them, they're not the right factors, because that only adds up to 5. I want it to add up to 7. So instead of guessing 3 first and 1 second, let's guess 3 first and 1 second. No, that's what we just did. 1 first and 3 second. So then if I do my second guess, this becomes n, and this becomes 6n, which adds to 7n. So that checks. That's a check. So there's your factors for that expression. Again, if you don't truly remember that, it's okay. We're going to do it again this year. Number 8 says, let f of x equal x squared plus x minus 30 and algebraically determine the values of x. Notice the word algebraically. There is a way of graphically doing it. We'll talk a lot about that in class this year. But for this, we're really just going to set f of x as 0 and do some factoring. So what multiplies to make negative 30 but adds to make 1? So those are going to be two numbers next to each other with opposite signs. I'm going to say positive 6 and negative 5. Each one of these expressions then can be equal to 0 using something called the zero products law. And we get two answers of negative 6 and positive 5. Number 9 says, a function is shown to the table to the right. If added to the table, which ordered pair would result in a relation that is no longer a function? Functions are special because they don't have repeating x values. So we're looking to see which of these points would create a repeating x value. So that would be this point. So negative 4, 1 would create a non-function, right? And the reason why is because it would have a repetitive x value, right? The x values have to be unique and different from each other if it was a function. If something has a repeated x value, that means the graph of it is going to have a point here and a point right down below, which would fail what we call the vertical line test. For number 10, we're asked to evaluate this kind of odd looking expression, but we'll talk about what that expression really means to us. So it says f of 3, so I got to plug in 3. 3 squared is 9, 2 times 3 is 6, 9 minus 6 is 3. F of 1, I plug in 1, I have 1 squared, which is 1, minus 2 times 1, which is 2, so we have 1 minus 2, which is negative 1. All divided by 2 because 3 minus 1 is 2. So then we wind up getting 4 over 2, which is just 2. That's my answer for what they're asking us to evaluate here. Now, what this expression means is the average rate of change. Of f of x. So how we would show that is we'd say the change in f over the change in x is equal to 2. So essentially what this is saying is the function is changing at a rate of 2 when we go from 1 to 3. That's your homework. Hopefully you got everything right on that first page. If you kind of forgot some stuff on this second page, don't freak out. We're going to review all of it in class as we keep going deeper and deeper into this chapter. Best of luck, and I will see you all tomorrow.